Hello guys, hope you are doing extremely well. Let's move on to the next problem from our tree topic in Blind 75 series, and it is binary tree maximum path sum. Let's continue our discussion with the problem statement. It is marked as hard level problem, but it is pretty easy. I will explain it in such a way that it will become very easy for you and you will be able to solve it on your own. Okay, what it is saying? It is saying a path in binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Okay, note that the path does not need to pass through the root. The path sum of a path is the sum of nodes value in the path given the root of binary tree. So here they are explaining about the path, how we can imagine a path in the given binary tree. Now they are telling what we have to do. We have to return the maximum path sum of any non-empty path, and we will be given a binary tree through root. Okay, let me explain you with an example. So I have opened this whiteboard for explanation purpose. Let me clear the previous things. Okay, all right. What we have to do here is, suppose the binary tree which is given to us as input is this. 10 is the root node here, and its left child is 2, right child is 10, and 2's left child is 20, right child is 1. Okay, then 25, and say it is having 3 and 4. Now this is the binary tree which is given to us as input. Now we have to find the maximum path sum. They have explained us how we are going to imagine this path, and then we'll find out the sum. How we can create this imaginary path? What we can do, we can start from any node, suppose this node, and with the adjacent nodes we can move ahead like this. This can be our path, and in our path the nodes that are coming, we can add all the values which are contained by nodes, and that will be our path sum. And we want the maximum one. We will choose such a path which is containing the maximum sum. All right, so suppose this value is negative, because then only we have to make choices of taking a node or not, taking a node's value or not. So suppose this is 25, so we want our sum to be as large as possible, so we'll avoid this 25. Okay, now one thing is more given there, that this path need not to pass through the root. Okay, this is the root, means it can be like this also, starting from here, then here, then here. It can be a valid path, and if the sum is maximum, then the sum of this node's value, this node's value, this node's value will be our answer if they are containing large values. Okay, so now we have understood that what we have to do here. Now we will see the intuition, how we will manage to reach our code. So the intuition here is that for every node we have to make few choices. Suppose we are standing at here, we'll start making recursive calls from the root node, and eventually we'll reach the leaf node where there are no further childrens. Now what we are going to do, from here we will return to the previous call. So while returning, what we will do, we have certain options, we have certain cases. Here we have only 20, so we'll return this 20. But what we are going to return? We want to return the maximum possible value from any node to its parent. Okay, we have seen this. Now let's consider this node. While we are standing on this node, what we are going to check? See, let me take some other color. Suppose I am standing at 2. So what are all the options do I have here? I can take this 20 and 2 in my path. So one option is that I have is 22. I can make path like this, and other option is that I can make path like this 22 and 1. So what will be the sum? Now current sum is 20 plus this 2 is 22. The other option we have is 20 plus 2 22 plus this 1 means 23. We can take this 22 also, we can take 23, and suppose these values would have been negative values, then what we are going to do? We are going to return only the root node. Here it is, they are all are positive. So there can be a case when root is largest of all of them. Suppose this is 200, then it is minus 20 minus 1. Then what we should return from this node to its parent? We should return only 200, because these values are reducing the current sum, which is 200. So it is better for us to not take these nodes in our path. So we'll decide like this only. While standing on each node, we have 3 possible cases. Case 1 will be whatever the answer of left subtree, left sum plus root plus right sum. And here left sum and right sum are the sum which are returned by left subtree and right subtree. Okay, this is case 1. What will be our case 2? Case 2 will be if we are taking only left plus root. This can be a case. And case 3, here it will be sum, right sum plus root. If the left value is in negative, it is reducing the current sum, so we will not take it in this case 3. And case 4, what it will be? It will be when we are taking only root's value only. If these are this case, we will consider when these nodes values are in negative. Currently all are positive. So what we are going to, which case we are going to take? We are going to take here, consider here case 1. Okay, now case 1 says that left sum, it is 20, because left tree sum is maximum path sum is 20 only, one node is present only. Here it will be 1. So 20 plus 1, 21 plus 2, 23. So 23 will pass from here. But you see, path can be like this and like this. It cannot be like this, means having multiple ends. It can have 2 ends only, starting somewhere and ending somewhere. So we have all these values, and we'll check which is the maximum one. And here we have maximum as See, let me write the sum here only. It is for this node. I am talking about this node. 23 left plus root 22, and right plus root, it is 3, root only it is 2. So what we are going to pass, we are going to pass from these three only. Will not pass this 23 because path cannot have multiple ends. So we'll path maximum of these three values, which is 22. So 22 will reach here from this subtree. And while considering our answer, we'll check maximum for all these values and store it. Currently here is 23, so we'll in our answer we'll store 23, because this can be a path if we don't want to go further in the top. So this can be our answer, this can be our required path, and this can be answer. The current answer is 23. We'll eventually maximize it. All right, similarly we'll do in the right side, and we'll start from this node. Okay, so what are all the options we have here? We can have minus 25 plus 3, it will give us minus 22, and minus 25 plus 4, minus 21. And if we add all the values, it will be minus 25 then plus 7, means minus 18. Okay, so is minus 18 greater than 23? No, it is not. So no need to update our current answer. It is 23 only. Okay, now what we are going to pass? So here in this case, the case 2 is containing minus 22, case 3 is containing minus 21, and case 4 is containing minus 25. Which is the largest value we have here? It is minus 21. So we'll pass minus 21 to its parent. So 21 came here. Okay, now with this node, what are all the options? So its right sum is minus 21, and its own value is 10. Minus 21 plus 10, it is minus 11. And we'll check. We are taking this case. In this case we are checking with our answer. Is it greater than our current answer? No, it is not. So we'll not update it. And now we'll see what we have to pass to its parent. What we'll pass? We have certain options. Let me show you. So I am erasing the previous values now. So for this node, left plus root is minus 11. Right is 0. So right plus root, it is 10, and root alone is 10. So which is the largest value here among all these values? It is 10. We'll pass 10 from here. 10 will reach the root node. Now here in the root node, we'll find out values for all these cases. So case 1, left sum root right sum, it is 22 left sum, 10 right sum plus 10. It will be 22 plus 10 plus 10, 42. So 42 is our current sum of current path. Is it greater than 23? Yes, of course it is greater than 23. Now we'll update this 23 with this value 42. Now 42 is our current answer. Okay, now do we need to pass anything further to the top? No, we are currently our root node only, so there is no need to pass anything to the parent. So we'll stop here. We will reach the original call, will come out of the recursive function, and our final answer is holding 42, which we are going to return. So yes, this is the correct answer, and the path is this 20. It is not visible. Let me take green. So 20, then 2 is also included in our path, then 10, then this 10. 20 plus 2, 22 plus these 20 of 2 tens, it will, all the values will sum up to 42. So yes, the correct answer in this case is 42. See if you can find any other path which is having more sum. No, we cannot have, we have to take this largest value 20, so we will not take this one. And here below in the right side we will not take anything, because this minus 25 is only reducing our answer. Okay, so now we have understood intuition how we are going to code it. Let's jump on to the code and see how it is working, and the concept will become more clear for you. Create the helper function. So the main logic of calculation of max path sum will happen in our helper function. The given function will only call it and return answer. Let's start with helper. As the given function, it will also take the root of the given node. Now we'll check if the root given to us is null, then the sum will be 0. Okay, and if it is not the case, then we have a node, then we will do some calculations. First we'll check the left sum. We'll call the recursion with left subtree, and with this helper function it will return us max path sum in the left subtree, like this, helper root left, like this. Okay, similarly we'll do for the right side. It will be helper root right. Okay, now we have calculated the left sum and right sum, which are containing the max path sum from left subtree and right subtree while standing on the current node. Now we'll create the cases that we have discussed. So the case 1 will be, it is sum of left subtree and right subtree plus root's own value. Okay, and case 2 will be maximum of left sum, right sum and roots value. This we have discussed. See, from I have combined case 2 and 3 because we will take only, while passing to the upper call, we will take only the one of them, that is left sum or right sum. So I will take the maximum of them. Alright, and I've already added this root value. Now the final case will be case 3, and it will be root's own value if it is the largest among case 1, 2, 3. Now what will be our answer? Here we will maximize our answer. Let's create answer which will initially hold the minimum possible value. It is int min, and eventually will maximize it, and finally it will attain the maximum path sum. So it will be max of, and max of what? Here we will compare all the cases, case 1 with case 2. Okay, now case 3 also, and one more thing that is left. Can you guess? Yes, as we have to maximize, so we'll also maximize it with itself answer. Okay, now we have calculated our answer and updated it if while standing on a current node we are getting current path sum as maximum value. Now what will return? So the returning case is that we'll only compare case 2 and 3, this 2 3 4. So I have combined 2 3, so I will compare here case 2 and 3. Case 1 I will not pass, will check for maximizing purpose, so I have compared it here while calculating our answer. So we'll pass case 2 maximum or case 3 like this. Okay, and from here we'll call our function helper and we'll pass root only and return our final answer. It will be finally stored in answer variable. All right, now let's try to run it and see if it is working. Yes, it is working fine. Now let's try to submit it. Yes, it got accepted successfully. So I hope that I have made it clear and made it easier for you to, so that you can code it for from your own. Okay, this is it for this video. If you want more such videos, you can consider subscribing my channel. Thank you. I will see you in the next video.